Questions on 103, 104 that I can help you with? Questions on 103, 104 that I can go over? Yes. You got yours.
Oh yeah, my good.
I got you. I came by and saw.
11.
11. That would be on 104. Number 11. Okay. The directions say for each of the following, explain in a sentence, or a phrase is fine with me, why the data display in parentheses is not appropriate for the data being collected. So for number 11, 30 scores out of 30 on a geography quiz, and they want it as a STEM plot. The reason I would not use a STEM plot is you would only really have only one stem. You'd have 2 as the left side, and then you'd have, any of the values, because there's nothing that's outside of the 20s.
You could do like 21, 22, 23, 24.
That I would do as a dot plot.
Yeah.
So dot plot would be probably better to look at that. Well, so a stem, if I did a stem on that, you would have it look like this. You got a 1, you got a 2, you got a 3, no, I got a 4, yes.
I just said it wasn't in order.
No, order would be fine. So this is not dumb, but this is what your stem and leaf would look like. A dot plot you could do as 20, 21, 22, 23, 24, 25, etc. And then you'd say, okay, there's a 22 and a 25. There's a 26, so if you had that, you'd have another 26, so on and so forth. It's already happening. Hey, good stuff. All right, kill that. No, reopen. I think it's because I'm recording and projecting on 2 devices at once. My computer doesn't like it. All right, other questions off of page 103, 104. I need to go to Desmos as well. Graphing calculator. Close. All right. Anything else off the homework I can help? We're good? All right. Let's see. 1-6, so page something. 1-6. All right. So I'm on page 12 and 13. Hey. How's shoulder?
All right.
Yeah.
You just read that?
I haven't seen anyone but mine get older. So.
Oh.
All right. So I'm sure that you know what the mean is. It's the average, right? So if I took like what you got on the last quiz, added up all the scores, divided by the total number of people, I would find the mean, right? So the mean is the average. So the mean itself can be influenced by something called outliers, something that's really big. Like, have you ever been in a class where you get that one kid that probably shouldn't be in there? Like everyone gets like a 12 out of 30, and then you get the one kid who gets a 30 out of 30.
Yeah.
That's going to impact the average. That's going to bring the average up. So the average is not resistant to outliers. So it's not resistant to an outlier. Okay, now, You might also see this just in a neighborhood. You ever like drive through a neighborhood and there's that one house that is either so much nicer or so much crummier than all the rest? Okay, I don't know if it really happens in Greenwood Village, but like if you were to go to kind of the outskirts of town where you might have some ranches, you might have some really nice houses, and then you have that 2-bedroom, 1-bathroom, looks like it never got painted since 1955. So that might lower the value of what the average price of the houses would be. Okay, they have an example there where they have data set 1 that's halfway down on page 12, where you have 6, 4, 5, 7, 4, and 6. If you add all those together, divided by 6, you come up with a mean of 5.3 or 5.33. If you have the exact same data set of the 6, 4, 5, 7, 4, 6, and then you had one more score of a 30, the 30 is going to move the mean up to 8.86. So the mean is not resistant to something called an outlier, something that's out there. So I bet you you have gone someplace and you pull into a parking lot and you have just normal cars, and then you got the one guy that pulls up and they're driving the Lamborghini. Well, the average price of the cars just went up in that parking lot because the Lamborghini is a very expensive vehicle versus just the average. Hello. Good to see you.
You too.
So kind of think about what that is, and we're on page 12. And if you have the homework, I can double check it for you. All right. The other measure of our center of spread is something called the median. And the median, look what happened. The median is the middle. Just can't have nice things, I guess. So the median is the middle of the data. The median is not pulled one way or the other. So a lot of times they will say that the median cost of a house or the median cost of a car or something like that is, close to the center. So if I had, let's say I had number values like 1, 2, 3, 4, 5, and 6. So if I found the average, it'd be 3, 6, 10, 15, 21 over 6. And somebody on their phone, do 21 divided by 6 for me, please. 21 divided by 6, anybody? 3.5. Cool. Okay. But if I want, so this would be the mean. And the mean is represented by having an X with a bar on top. But if I wanted to find the median is the middle. And if I have two numbers as the median, you take the two middle numbers and divide them in half, and you come up with that the median, in this case, would be the same idea. Now, the median doesn't have a special symbol or anything like that. So the median is the middle of the data. The mean is the average of the data. Yes, the mean and the median can be the exact same thing. So if I were to change this slightly, and I said I have 1, 2, 3, 4, 5, 6, and say 20, that's going to be, let's see, 41 divided by 6. 41 divided by 6 is what? How much? 6.8. Okay, almost 7. I like a guesstimate. That's good. So that's our mean. That's our mean. It happened again. Oh, no. But my median is my middle number right here. Just give me something nice. So my median of that would just be 4. Okay? Okay? So if you look at the data Yes, the median did change a little bit because I added one more number, so it went from 3.5 to 4. So it's pretty resistant, whereas the mean, by having a score of 20, going from a 3.5 to a 6.8. Okay, so one is resistant to the other. Okay, and I think I can get the rest of this on Desmos. Okay, so let's jump on Desmos. Accident in I-25 North. Good. Okay. Hope everybody's okay. All right. So let's do a list, and let's just make up. These were the scores of a In the Mind of Stirrup. Okay, let's say those are the scores of a quiz that I had given to a certain class. Now, we've already dealt with using this where we could look at a histogram on Desmos. But what you can also do on Desmos is if you go to your keyboard, you go into Functions, and go to Statistics, you could find the mean, you could find the median, and then all I'd have to do is I'd say, hey, what's the mean of L? What's the median of L? So the mean of L is a 16.1. The median of L is 16. So the calculator or Desmos will do it for you, which is beneficial. Now there's other things that we will start finding on this. So let's just make sure I covered everything. We have the mean. Okay, another word for mean is also expected value. Okay, that comes from the middle of page 12. So on middle of page 12, make sure you mark mean and expected value. Same thing, so somehow circle that. So if you refer to that in your notes. So it means that you would expect to get that. Okay, now, I don't know, like if I said if the average on the last quiz was say a 25.5 out of 30, and whatever it was, and you came in and say, well, what would you expect me to get on the test? I'd expect you to get about 25.5. That's the mean. Now, does that mean that the person truly will get 25.5? No. It means that I would expect somebody who came in and took it at a different time would get right around the mean. Okay, so it's the expected value. But again, outliers, things way too far to the right of our data or way far to the left of our data, are called outliers. They will impact the mean in a way that you don't necessarily want. So let's say if I just added one more thing to this list, if I added, let's say someone busted out a 39. So look at how the mean changed up to an 18.8, median is 17. Maybe if I change this to, let's say someone got a 65, look at how the mean is increasing where the median's staying the exact same. What if I said if someone got an 89? So now the mean is a 22.7, the median is a 17. So the mean is influenced by something that's way too far to the right of our data or way far to the left. Okay. So other things that we talk about is the percentile. The percentile, the 50th percentile and the median are the same thing. The 50th percentile means half the scores are above it, half the scores are below it. So the 50th percentile and the median are the same. The median is considered to be resistant to outliers. So it's not going to get pulled one way or the other due to outliers. So if I were to say, oh, wow, this dates us. So they said the median gas price is $2.20 a gallon. Boy, wouldn't that be nice? That means that 50% of the data would be above the $2.20 and 50% of the data would be below $2.20. And we must be gone way back in time on that one. Okay, so 50th percentile is the median, and we will talk about some other things more on Desmos as we progress further. So 1-6, 1-6. All right, so I can do this. This will work. So let's have us work on six. Let's have us work on page 105 and 106. Okay. I will tell you that tomorrow we're actually going to do a little review from 104 to 1-6, but that doesn't mean I have a quiz. I already gave you a quiz. Mr. Anderson's going to give that quiz. He didn't give the previous quiz. Okay. So rather than give you another quiz on Thursday, we're just going to keep moving along. Okay. Deal? You know what to work on? I'm done recording.